Welcome to the LeetCode Larry Show. I'm your host, LeetCode Larry, the only guy on the planet that goes by LeetCode Larry, whose name is not actually Larry. Today we're going to do some LeetCode, some easy LeetCode. Let's look at the blind 75. Let's go through this list. So there's a bunch of, categories in the blind 75. We got array, binary, dynamic programming. But for the, for the next 5 to 6 videos, we're going to do nothing but arrays. Arrays have their own patterns themselves. There's 2 pointers, there's a sliding window. I don't see sliding window here. Sliding window, its own thing. Oh, so string has sliding window. But we're going to do arrays. Maybe we'll do arrays and strings, but today we're going to start with arrays. We're going to do one of the easiest questions called contains duplicate. So let's go ahead and start and look at this one. Once again, this is part of the blind 75, probably the most popular LeetCode list you can find. Let me go ahead and set this to Python. Okay, so what is the question here? Let me go ahead and read it. Given an integer array, nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So they give us this first example here called nums, and so it returns true if there is a duplicate value. So in this array, it's going to be, we had the elements 1, 2, 3, and 1. So the duplicate obviously is 1. We can look at this easy example and we see what a duplicate is. And just for one more example that returns false, we'll look at this next example. The elements are 1, 2, 3, 4. Now we notice every value in this array is distinct. Every value is unique. There's no duplicate, so we return false. So how do we approach this problem? A brute force way of doing this, you could, so we could iterate, we could take this array. Let's start with the example array here that they're given. We could go through each element in the array. And for each element in the array, we have another loop. So I guess let me start over. We have an outside loop, we have an inner loop, which is not always a good thing. So the outside loop is going to loop through every element, and the inside loop is just going to loop through each element after the element. So we start with this first value, this first element. We're going to loop through every other element in the array and see if it matches. So in this case, it finds it pretty quickly. You can start with 1, you loop through every other element, and you'll see that it's 1. But let's take the second example. Here, we're going to have to iterate through the entire array, and we're going to have to do a subarray and a subloop every time. So what's the runtime complexity going to be for that? Well, it's going to be on the order of n squared. It's going to be a quadratic time algorithm. So for each element in the list, we're going to have to iterate through, n-1 elements in the list. When we start with 1, we're going to iterate through every other element and check. And 2, iterate through the rest of the elements and check. When we get to 2, it'll be n-2, so it's not technically n-1 every time. But it will, if you do some discrete math, you'll see that it ends up being n squared, order of n squared. But you don't really need discrete math to figure this out. You can kind of intuitively see that you're going to have to do this unnecessary extra loop each time. But what's a more efficient? Well, by the way, I should say that the space complexity is actually constant, so that's one benefit of doing it. But so let's say we want to use some extra space complexity. How could we speed up our algorithm here? Well, there's a few key data structures that you can always use, but let me save you the suspense. We're going to use a set here. You can call it a hash set in Java, or there's other sets in Java, but Python, they just call it a set. I'm actually not sure how to declare it in Python. I might have to Google that. But we're going to iterate through each number in this array. And each time we iterate through a number, we're going to add it to the set. And adding to a set and looking up in a set is both constant time complexity. I might make another video in the future that explains why that's so, but for now we just need to know that doing a set lookup, looking for a value, and adding to a set is constant time. It's order of 1, big O of 1. So let's go to this first example here. What are we going to do? We're going to look at the first element. We're actually going to check if it's in the set. If it is in the set, we can return true. That means we know we've found a duplicate, because that means we've already, saw it earlier. If it's not, we're going to add it to the set. I guess I'll, let's see here. How do I make this a little bit bigger? So for this first example, let's just go through the whole example. First, we look at 1. 1 is not in the set, so we add it to the set, and we continue. We look at 2. 2 is not in the set, so we add it to the set, and then we continue. We look at 3. 3 is not in the set, we just have 1 and 2. So we add it to the set, and then we continue. Now finally, we look at 1. Is 1 in the set? Yes, 1 is in the set. So we return true. If, however, we would not have found it, if we got to the end of the loop and we never found a duplicate, we would return false. And then let's take one more example. Let's look at this 1, 2, 3, 4 example. I guess it's very similar. I'm just repeating myself a little bit here, but let's just go through it. So we look at the first element. We have a 1. Put 1 in the set. With a 2. We check the set for a 2. We don't have any 2. We just have a 1. So we add 2 to the set. We continue on. Now we look at the 3. Is 3 in the set? Nope, we only have 1 and 2. So we continue on. We add 3, then we continue on. Our last element is a 4. Is 4 in the set? 1, 2, 3. Nope. We add 4, then we continue on. Oh, but we're at the end here. So we never found a duplicate. We never found an element that was already in the set. So we return false. And it should be noted, so what's the time complexity here? We only looped through the array once, and we were performing constant time operations each time we, looked at an element. Like I said, a hash set, you can do a lookup, and you can do an insertion in constant time. So you're just doing constant time operations for each iteration of the loop. So that means this is going to be a big O of n. See if I can draw a big O of n. Big O of n time complexity. Now what's the space complexity? Now in this case we had to give up some space efficiency for some time efficiency. So the space complexity here is again big O of n. Why? Well, in the worst case, the set can be, like in this second example, the set can be as large as n elements. The set can have as many elements as are in the list. The space grows for the algorithm, the space required for the algorithm grows linearly with the size of the input, the list. So we got some intuition here, we sketched it out. Let's go ahead and do some coding. Let's see here, do I have my docs up? Let's do some docs.google.com. I need to get this ready in the future. Okay, so what do we want to do here? Let's code up the solution in Google Docs, but let's look at the format in LeetCode. So it's called contains duplicate. Define contains duplicates. Let's go ahead and just get rid of some tabs here. And so the input to this function, this method, function, whatever you want to call it, is a list of integers nums. Once again, as I just explained, we need to return true if there's a duplicate, false if there's no duplicate. So how do we do this? Well, we need a set. Just call the set hash set. I think it's just initialized like this in Python. I should probably do some more preparation before these videos, but oh well. So we got this hash set. What are we going to do? We're going to loop through each element in this list, in this case nums. For each element, we're going to check if the element already exists in this hash set, which is a constant time operation. If it does, we return true. If it doesn't, we add the element to the set and continue on. Okay, so for num in nums, if num in hash set return true. And if it's not in the hash set, what do? We do hash set dot add, I believe, num. And at the end, if we don't find a duplicate, so at the end of the for loop, if we don't return true, we don't find this duplicate, we're gonna return num, we're gonna return false. We're gonna return false because we never found a duplicate. So here's the Google Docs is annoying. Here's the code here. I like sketching it out in Google Docs for it's good practice for leak coding interviews. So here we go here. You can go ahead and copy this, but the formatting is going to be a disaster. And we're going to try this in the LeetCode problem here, and the contains duplicate problem. We're going to see if this works. Let's say, make sure the formatting is correct. Hash set for num and nums. If num and hash set, return true. Add num. Voila! Okay. It works. And if you look at the solution, this is the optimal solution. I explained that linear time searching. You can also do a sorting. You can also sort. Maybe I'll make another video how to do that, just for a brain exercise. But contains duplicate using a set. They have the Java solution here, is the most efficient time approach. But if you're new to LeetCode, or if you're not new, you probably already know this. But if you are new, just worth pointing out that this isn't exactly accurate. Or maybe it's accurate. Maybe that's not the right word to say, but it's maybe a little misleading at times. This is the fastest approach. Just because it says 10%, only faster than 10%, doesn't mean it's a bad approach. You'll get a different number each time. Sometimes, see, look, I got 31% this time. I don't know how I went from 10% to 31%, but that's how it works. So all in all, we've solved our first LeetCode problem in the blind 75. Go back to this. Well, yeah, we solved the first problem in the blind 75. Our array problem. In my opinion, this is the easiest problem. Some might say 2sum is the easiest. I'm going to go do that one next. But I think contains duplicates the easiest problem to do. And I think it's a good exercise learning how sets work, learning how, the time complexity of set operations. I think that's mainly what they're looking for in a problem like this. Alright, but once again, I'm LeetCode Larry, the only person on the planet named LeetCode Larry, whose name is not actually Larry. Thanks for watching. Ciao.